Hello, this segment is Pythagorean relationships. Pythagoras was a mathematician who had opened a school in southern Italy back in the 1900s, early 1900s, where he had first presented this method of measurement to the world. But that is not where it first originated at. It was first originated approximately 4,000 years ago in Egypt, where it was used extensively. But Pythagoras learned this formula and presented it to the world as an effective way of measurement. It is the use of an algebraic equation to solve for an unknown side of a right angle triangle. The right angle triangle, a 90-degree angle on the inside of a triangle, where you have legs of the triangle, which are considered A and B, and the hypotenuse, which is the longest side, and also the side directly across from the 90-degree angle, is understood to be C. The hypotenuse is the side C. So, for example, if I was to have a right triangle or a right angle triangle, how do I know that this is a right triangle? Because it has that little box in a corner or in a angle on the inside of the triangle. It's a 90-degree angle. 90 degrees. That's what a right angle triangle or right triangle is. It's a triangle that has a 90-degree angle on the inside. So, Pythagorean relationship states that a square plus b square is equal to c square. This is the formula for Pythagorean relationship. A square plus b square is equal to c square, where a and b are legs of the triangle and c is always the hypotenuse, the side across from the right angle, that is C. A and B are just the other two sides of the triangle. You call it the legs of the triangle. It does not matter what side you call A, and it does not matter what side you call B. What matters is that you always call the hypotenuse C. So the formula works, because A squared plus b squared is equal to c squared, where a and b are legs of the right triangle and c is the hypotenuse, the side across from the right angle. For the formula to work, it must be a right angle triangle and c must be the side across from the right angle, which is the hypotenuse. Please remember this. So a squared plus b squared is equal to c squared. So for example, if they gave me a right triangle and they said that this side was 3 feet and this side was 4 feet, what is x? The unknown. So what I have to do is I have to apply Pythagorean relationship to find out the length of that side. So I set it up in an algebraic equation using this formula: a squared plus b squared is equal to c squared, where a and b are legs of the right angle triangle. So it doesn't matter, like I said, it does not matter which side you call A and which side you call B. I just fill in my formula by substituting letters for numbers. So A would be 3, so I said A, which is 3, and I make sure I put back my square, or the second power. A number squared or a number to the second power just mean that number multiply by itself. So for example, if I had 10 squared, or 10 to the second power, this is actually 10 times 10, which is equal to 100. If I had 9 to the second power, this is actually 9 times 9, which is equal to 81. So a number or a variable to the second power is just that variable or that number times itself. So if I, for example, I had x to the second power, or c to the second power, or a to the second power, x to the second power is equal x times x, c to the second power is equal to c times c, and a to the second power is equal to a times a. I cannot solve this or these because I do not know what x, c, or a is. If they had given me a number, I could have solved it. But actually, x to the second power just means x times x. Any number or variable to the second power just means that number or variable times itself. So, to substitute or to fill in my formula, because that's what you do. When a formula is given, all we do is we substitute the letters in the formula for what the numbers are, so we could solve it. So in the formula, this is the formula for for Pythagorean relationship. A squared plus b squared is equal to c squared. That is the formula. So 3 squared, because I said A is a leg of the right triangle, and this side is 3. 3 squared, bring down my operation, which is plus. B, which will be 4. 4 squared is equal to C, which will be x squared. Now, remember, in order of operations, the first thing you want to do is exponents. Exponents mean whatever it is to the power. The second power, the third power, the fourth power, the fifth power, the first power, whatever it is, that's what an exponent is. Like x to the second power, the 2 is an exponent. And you want to solve that. I will also try to squeeze in the order of operations in this segment if I have time. It's very simple. It would not take long. But we need to know the order of operations, so when you go to try to figure out or to solve an equation, you follow that order. What should you do first? So here I have 3 squared plus 4 squared is equal to x squared. So I work out what the exponents are. 3 squared just means 3 times 3, which is 9, plus 4 squared means 4 times 4, which is 16, is equal to x squared. So 16 plus 9 is 25, so 25 is equal to x squared. But remember that in an algebraic equation, this is not solved as yet. You're not trying to find out, you're not trying to figure out what x to the second power is, or what 2x, 3x, or minus 4x is. You always want to find out what the positive variable is by itself, what x is by itself, what m is by itself, what y is or x by itself. Positive x, positive y, positive m, positive 1x. Positive 1x is what I want to find out right here. So if I have a variable to the second power, and I'm trying to figure out what that variable is by itself, I have to get rid of that second power. And how do I get rid of something to the second power? I find the square root of that variable or that number. So the square root of x to the second power is x. The square root of any number to the to the second power is that number by itself. The square root of any variable to the second power is that variable by itself. So in this case, I have x squared, and I'm trying to find out what x by itself is. So I find the square root of x squared. The square root of x squared is x. And whatever I do on this side, I do the same on this side. So I find the square root of 25. Bring down my equal sign. The square root of 25 is 5. So x equals 5. So this side, x equals 5. So that's 5 feet. So in a right angle triangle, if the legs are 3 feet and 4 feet, the hypotenuse must be 5 feet. Say, for example, I have a triangle and I have the sides this is 9 feet, 15 feet, and here is B. We know B is a leg of the triangle. I could have called it X, but it's called B in this scenario. So it's a right angle triangle. I'm trying to figure out what is the measurement of one of the legs of the triangle. The hypotenuse is given. The hypotenuse is 15 feet. The other leg is given, which is 9 feet. And the other on the third leg is not given. We are trying to find that, figure that out. So the formula for Pythagorean relationship is a squared plus b squared is equal to c squared, where a and b are legs of a right angle triangle and b is the hypotenuse. C is the hypotenuse, the side across from the right angle. The hypotenuse is always across from the right angle. So I just substitute letters for numbers. What leg is A and what leg is B? They gave you this one as B, so call that one B. So did they give me A? Yes, A is 9 feet. So A squared, which is 9 squared, plus B squared is equal to C squared, which is 15 squared. That is how I just plug in my numbers in the formula. So now I have an algebraic equation where you have variables and numbers. Remember, in an algebraic equation, you cannot have variables and numbers on one side or on the other side. What side? On the side of the equal sign. You have to have all numbers on one side and all variables on one side, doesn't matter what side. But since I have the variable on this side already, and it's already positive, I'm going to leave it on this side. So I'm going to separate variables from numbers. So I want all variables on one side. I'm going to leave my variable on this side. It is b squared is equal to, and I bring down my 15 squared, my numbers that is going to stay on this side. I just drop it down. And this number on this side, I have to take over there to the other number, and anytime you change sides, the sign changes. So this is a positive 9 to the second power. So when it comes across, it becomes negative 9 to the second power. Negative 9 to the second power also means minus 9 to the second power. Same thing. Negative and minus is the same thing. Don't let no one trick you. So b to the second power, now I have to work this out. 15 to the second power is 225 minus 9 to the second power is 81. So 25 from 80, 225 minus 81, 8 from 12 leave 4, 144. So b squared is equal to 225 minus 81, which is 144. But that is not my answer. Because remember, I'm not trying to figure out what b squared is, or what 2b is, or b to the third power, or 5b. No, I'm trying to figure out what b by itself is, the positive entity of that variable. So to find out what b is, if I have b squared, and I'm trying to figure out what b is, I find the square root of b to the second power. And whatever I do on this side, I do on this side also, because that's algebra. So b, the square root of b to the second power is b, because the square root of anything, any variable or any number to the second power is just that number by itself. So the square root of b squared is b, and the square root, bring down my equal sign, and the square root of 144 is 12. So the side B would be 12 feet. If you have a right triangle and one of the legs is 9 feet and the hypotenuse is 15 feet, the other leg, which is the unknown, must be 12 feet. Please remember this. For example, if I have 6, 8, and I'm trying to figure out x. This is 6 meters. 1 second here. This is 8 meters, and I'm trying to figure out what x is, the hypotenuse. It's a right angle triangle, and they gave you the legs of the right angle triangle, the measurements of the legs. So you're trying to figure out what the hypotenuse is. The hypotenuse is the side directly across from the right angle. So you apply Pythagorean relationship formula, which is a squared plus b squared is equal to c squared, where a and b are legs of the right angle triangle and c is always the hypotenuse. In this case, it's x. So a squared, I substitute letters for numbers. Which side do I call a and which side do I call b? It does not matter. It does not matter which one of these sides you call a or which one you call b, as long as you make sure you call the hypotenuse c. If you don't do that, the formula will not work. So I have a squared, so I call 6a. So a squared would be 6 squared, plus b squared would be 8 squared, is equal to c squared, which is x squared. So let's work it. 6 to the second power, 6 is 36, plus 8 to the second power, 8 is 64, is equal to x to the second power. 36 and 64, that's 100. 100 equals x squared. But we're not trying to figure out what x squared is. We are trying to figure out what x is by itself. So if I have x squared and I'm trying to get rid of that exponent because I just want to figure out what x is, I have to find the square root of x squared. And whatever I do on this side, I have to do on this side also. So the square root of x squared is x. Bring down my equal sign. And the square root of 100 is 10. Because 10 tens is 100. So anywhere you see x, you put 10. So here, the hypotenuse is 10 meters. It is very simple. We know how to do algebra. We just did it in the last segment. So in Pythagorean relationships, you use the formula a squared plus b squared equals c squared, which is also an algebraic equation. And you just substitute the letters for the numbers. And sometimes, like I say, they give you the hypotenuse and expect that you should be able to figure out what the unknown side is. So for example, say for example they gave you this as 10 feet and this right here as 6 feet, and they want you to find x. It's a right triangle, so I apply the formula a squared plus b squared is equal to c squared. That's Pythagorean theorem or Pythagorean relationships. The formula is a squared plus b squared is equal to c squared, where a and b are legs of a right angle triangle and c is always the hypotenuse, the side across from the right angle. So a squared, which side do you call a and which side do you call b? Does not matter. You could call this a and this b, or you could call this a and this b. It does not matter, as long as you always call the side across from the right angle, which is the hypotenuse, you always call that c. You must. If you don't do that, the formula is not going to work. So x, let's say a is x to the second power, plus b to the second power is 6 to the second power, is equal to c to the second power. C is the hypotenuse, that's 10 to the second power. So what do we do now? We have an algebraic equation. We have variables and we have numbers. But variables and numbers cannot be on the same side. We have to move all variables on one side and move all numbers on the other side. So here I have, on this side I have variable x squared and I have number 6 squared. And on the other side I have 10 squared. So since I have the variable on this side already, I'm going to leave the variable on this side. So I bring it down and it becomes x to the second power. And I'm going to move the numbers across all numbers on this side. On what side? On the other side of the equal sign. I have 10 squared over this side already, so I just bring it down. And I have positive 6 squared on this side. Please excuse me. I have positive 6 squared on this side. I'm going to bring the positive 6 squared across and it becomes negative 6 squared. Because when you change sides, the sign changes. That's how algebra works. Anytime you change the sides, whether it's a variable or a number, once you change the sides, the sign changes. So here also, we're just going to work this out now. So x to the second power is equal to 10 to the second power is 100 minus 6 to the second power is 36. That's 100. So x to the second power is equal 100 minus 36. That should be 64. And we are not trying to solve for x to the second power. We are trying to solve for x. So if you have a variable to the second power or a number to the second power and you just want to know the number by itself, you find the square root of that variable or number. Whatever you do on this side, you do the same thing on that side. So the square root of x squared is x is equal to the square root of 64 is 8. So x would be 8 feet. Please, please, please remember this. remember Pythagorean relationships. You will see it again in geometry. You will see it again in algebra. You will see it again on some tests somewhere. And it's very simple. Pythagorean relationship works only in a right angle triangle where a square plus b square equals c square. That is your formula, where a and b are legs of the right angle triangle and c is always the longest side, the hypotenuse, which that's the side directly across from your right angle. Please remember these things. It is very important. I'm not going to do order of operations in this segment. I'll wait for another segment. I just want to take this time to show you an algebraic equation that I didn't show you in the last segment. This is an algebraic equation. When you have a parenthesis with a number in front of it, this means multiply. This means whatever is in this parenthesis is multiplied by this 2. And the same thing on this side. Whatever is in this parenthesis means multiplied by 3 on the outside. This is an algebraic equation. So what I have to do is get rid of the parentheses. And I'm going to show you that in the next segment when I do order of operations. It is so important that you know the order. But because there's no other order for me to do here, I have to get rid of the parentheses by multiplying everything inside by what's on the outside. So 2 times x is 2x, and 2 times negative 4 is a positive 2 times a negative 4. When you're multiplying or dividing and my signs are different, my answer will always be negative. So positive 2 times a negative 4 is a negative 8. I bring down my equal sign. And 3 times x is 3x, and 3 times negative 6, positive 3 times negative 6, when I'm multiplying or dividing and my signs are different, my answer will always, when I'm multiplying or dividing and my signs are different, my answer will always be negative. I think I said the same here. When multiplying or dividing and my signs are different, my answer will always be negative. So I have negative 2. I have positive 2 times a negative 4. That gives me a negative 8. And here I have positive 3 times a negative 6. That gives me a negative 18. So I have variables and numbers. I have to separate my variables from my numbers. I have to separate my variables from my numbers. So here I have 2x, positive 2x, and over here I have positive 3x. I love using my little rule that I formulate, bringing the smaller variable to the bigger variable. What is the bigger variable? The bigger variable is 3x. Here's my borderlines, the equal sign. So the 3x is going to stay on this side because it's bigger than the 2x. And I'm going to take the 2x across to it because I want all variables on one side. So I bring the 2x across, it becomes negative 2x because it's a positive 2x here. When it comes across, it becomes a negative 2x. And what do I have on this side? My negative 8 is going to stay on this side, so I bring it down. And I have to have all numbers on one side and all variables on the other side. So I have a negative 18 over here. I got to take it across the equal sign, and it becomes positive 18. But this is incomplete. So when I'm adding or subtracting and my signs are different, I find the difference and keep the sign of the larger number. You have to remember the rules. When I'm adding or subtracting and the signs are different, I find the difference and keep the sign of a larger number. The difference of 8 and 18 is 10. And the sign of the larger number is positive. So that's a positive 10. I don't have to put the plus sign there. It's understood to be positive. And 3x minus 2x is 1x or just x. So x equals 10. So anywhere you see x, you put 10. So 2 times 10 minus 4 is equal to 3 times 10 minus 6. Remember, you have to work what's inside the parentheses first. So 10 minus 4 is 6, and 2 times 6 is 12. 10 minus 6 is 4, and 3 times 4 is 12. It's correct. Let me do one more. I have negative 4 times y plus 2 is equal to 3 times y plus 2. So what do I have to do here? I have to work out, first of all, I have to multiply everything in the parentheses by what's on the outside. So negative 4 times y is negative 4y, and negative 4 times positive 2 is negative 8, because when you're multiplying or dividing and your signs are different, your answer will always be negative. So this is a negative 4 and this is a positive y. Negative 4 times positive y gives you a negative 4y, and negative 4 times positive 2 gives you a negative 8. Because the signs are different, when you're multiplying or dividing, your answer will always be negative. I bring down my equal sign. When I'm multiplying or dividing and my signs are positive, my answer will always be positive. So positive 3 times positive y gives you a positive 3y. And positive 3 times positive 2 gives you a positive 6. So here I have an algebraic equation where I have numbers and variables. Variables are just letters. So I have numbers and letters, and I have to take all letters on one side and all numbers on the other side. All letters or variables, same thing, on one side, and all numbers on the other side. My little rule that I formulated is I always take the smaller variable to the bigger variable. Here I have negative 4y, and here I have positive 3. Which one is the larger one? The larger one is positive 3. A positive is always greater than a negative. This is my borderline, the equal sign. So I'm going to leave the 3y, the positive 3y, on this side, and I'm going to take the negative 4y across the border, and when it comes across, it becomes positive because it's negative here. When it comes across, it becomes positive 4y. And what do I have on this side left? I have negative 8. So I'm going to leave the negative 8 on this side because I'm going to bring all my numbers on this side. And I'm going to take this positive 6 across the equal side, and it's going to become a negative 6. So negative 8, negative 6, when you're adding or subtracting and the signs are the same, you add the numbers and keep the sign. Remember the rules. Negative 8 minus 6, or minus 8 minus 6, or negative 8 negative 6, it becomes, I had the numbers and keep the sign, that's negative 14. Negative 14 is equal to, I have 3y plus 4y, positive 3y, positive 4y, that gives me positive 7y. But I'm not trying to solve for what 7y is, or positive 7y or negative 7y. I want just y. So to get rid of anything, whether it's an exponent or whether it's a number in front, I have to get rid of it. And in this case, to get rid of this number, I divide by the number. And whatever I do on that side, I do the same thing on this side. It's a positive 7, so I divide by a positive 7. That's going to leave me with a positive y. So 7 into 7y leaves me with positive y, or positive 1y. It's the same thing. Same thing. 1y or y is the same thing. That's what I'm trying to find. And 7, when I'm multiplying or dividing and my signs are different, my answer will always be negative. So negative 14 divided by positive 7, my answer is a negative 2. So y, or 1y, is equal to negative 2. Anywhere I see y, I put negative 2. So this is negative 2, and this is negative 2. So negative 2 plus 2, that's 0. Negative 4 times 0 is 0, is equal to negative 2 plus 2 is 0. Positive 3 times 0 is 0. So my answer is correct. Please rewind the video and look at it again. This is so important. I didn't do it in the last segment, I forgot. So I said I'll do it in this segment. Since Pythagorean relationship is a form of algebraic equation, I just added it to it. And it should help you, because you will see one like this on some test somewhere. So remember, Pythagorean relationship, again, can only be used in a right angle triangle where A and B are legs of the triangle and C is the hypotenuse, which is the side across from the right angle, the longest side. And remember your signs. When you're adding and subtracting and the signs are the same, you add the number and keep the signs. When you're adding and subtracting and the signs are different, you find the difference and use the sign or keep the sign of the larger number. When you're multiplying and dividing and the signs are the same, your answer will always be positive. When you're multiplying and dividing and the signs are different, your answer will always be negative. You learn these rules. You apply them. They work. Trust your formula. Substitute letters for numbers. Plug in where they go, and you cannot go wrong. I thank you for watching this segment. I hope it was very informative. The next segment is also a very important segment. I will do order of operations. This segment was Pythagorean relationship. It's a form of algebra, and I just added a couple of algebra problems that I forgot or had forgotten to show you in the last segment. So this is my 7th segment. I hope you learn and apply it. Thank you so very much.